And let's say that the first bit is a 1, and the second bit is a 0. Well, if I fix that and say that the first bit is on, I know that the number is at least 128, right? But if the second bit is a 0, the 64 position is turned off. And here's a little trick for you to remember if you want to speed through some of this stuff. If we take all the numbers to the left of any number, to the right of any number, I mean, the sum of all these numbers is always 1 less than this number. Okay? So if I add all these numbers up, I'm going to get 63. If I add all the numbers to the right of 32 up, I'm going to get 31. Right? Make sense? So if I've turned this 64-bit off, and I'm turning all the other bits left over on, the largest number I can make there is 63, or 1 less than 64. Right? So I know that every number that begins 1, 0 is going to be at least 128. And the largest it could possibly be is 128 plus 63, or 191. Sound familiar? You might have seen some of these addresses before, right? And then let's do one more. I'm going to say the first 2 bits are a 1, and the third bit is a 0. Now, again, looking at this, I know that it's going to be at least 128 plus 64, which is 192. And then let's go back over here. I've got the 32 off, but if I turn all the rest of these bits on, it's going to be 1 less than 32, or 31. 192 plus 31 is 223. Right? Got it? Now, if anybody has ever had any exposure to IP addressing, these numbers are very familiar to you. 0 through 127 is usually referred to as Class A addresses. 128 to 191 is Class B. 192 to 223 is Class C. Now, I need to revise that just slightly, because you always have to remember, if you're going to take the CCENT exam, who administers the CCENT exam? Cisco does. Cisco approaches this first class a little bit differently, because the 0 address, the 0 network is not usable, and the 127 is reserved for loopback. So Cisco's probably going to tell you that Class A is 1 through 126. That's fine. Either way, you see why it's that way. And if Cisco's giving you the exam, make sure you give Cisco's answer. Right? Now, what does this mean? Well, it's real simple. If I come over here and look at this address, and I look at the range of numbers, I see that it falls into the Class B range. And what that means is, I'm going to use the first 2 octets as the network ID, leaving the last 2 as the host ID. So I'm going to call this 131.161.10.20 a Class B address. Okay? Does that make sense? Let's take an example of a Class A address. Class A address might look like this. 10.10.10.10, right? Again, look here, it's between 0 and 127. So I know that it's a Class A address because I know that in an 8-bit binary string, the first bit is a 0. It has to be. Okay? And then I'm going to give you another address, 192.168.1.2, and then let's put that, let's look and see, that's a Class C address. Now here's why this is important. The Class B address uses the first 2 octets for network ID, and the remaining 2 for host. The Class A uses the other scheme, but only the first octet is used for the network ID, and all the remaining bits are used to identify hosts within that network. Okay? And the Class C uses the first 3 octets to identify the network, leaving only the last octet to identify the host. So which is bigger? Which has more hosts in it? A Class A or a Class B? Well, clearly a Class A does because it has more bits for identifying hosts. But which are there more of? Class A or Class B networks? Obviously Class B, because there are more bits for identifying those networks. All right? And the Class C networks, while there are many, many of them, are very small. Okay? And it's funny because if you look at these numbers over here, you can assign a number value to each one of these. And that's how many octets they use to identify the network. Class A uses the first octet only, Class B uses the first and second octet, and the Class C uses the first 3 octets. All right? Make sense? Everyone follow that? On the video, if you have a question, just raise your hand. All right, now computers are very literal. They see things very literally. They don't assume things. You have to tell them everything. And so in order for the computer to understand how I've decided to use Class A and Class B and Class C addresses, I have to present the address in a way that makes it absolutely clear which decision I've made. And I'm going to do that by using a mask. A mask is used, what does a mask do? Well, it covers things up, right? You can use it to cover up your face. If you're spray painting something, you can use it to cover up the things you don't want to get paint on, whatever, okay? I do the same thing with a subnet mask, right? All it does is it masks off the portion of an address that I don't want you to use or to see, okay? For example, if I'm sending a packet on the internet and it goes through multiple routers, each router only needs to know the network ID. It doesn't really care about the host ID until it reaches its final location. And that router will say, oh gee, I know who this host is, I'll make sure he gets the frame or the packet. But as it moves through the internet, the only thing that matters is its network ID. So I want to mask off the rest of the address. I want to show it that I think these bits are used to identify my network and ignore these bits because they're not important for you to look at. Okay? Now in order to mask off the address, I'm going to use a very simple binary arithmetic trick. It's not a trick, I guess it's just an operation. I'm going to call it AND, but I'm going to use the plus sign, but it's not plus. Okay? Don't confuse this with plus. I'm not adding, I'm doing a binary AND. And this is a simple rule. 0 and 0 equals 0. 0 and 1 equals 0. 1 and 0 equals 0. And 1 and 1 equals 1. Now if that's confusing, just think of electrical switches. Okay? If all the switches are on, current can flow from one end to the other. But if any switch is off, or 0, no current flows to the other end. Right? If there's a 0 present, no matter where it is, I always get 0. It's off. But if I have two 1s, that's the only way to obtain a 1. Okay? Now let's take that IP address where we're looking at 131.161.10.20 and write the first octet in binary. And then we'll write our mask that we're going to use. And the mask we're going to use right now is either 255 or 0. Right? 255, as you already know, is all 1s. 0 is all 0s. So let's take the 255 and write it in binary. Shouldn't be very hard. And then we're going to perform this binary AND operation on each bit as they're lined up vertically here. So 1 and 1 is 1. 0 and 1 is 0. And I keep going. And you'll see I get what I started with. I get what I started with. Okay? So the value of this is I can use a mask to expose certain parts of the IP address to the router by ANDing it with 1. Now let's take another part of that IP address, the 10. The 10 in binary looks like this. Okay? But if you recall, I said that that address was a Class B address. Let's look at it again. And what that means is this identifies the network and this identifies the host. So when I pass this IP address to a router, I don't want him to look at this octet. It's not important to him. Okay? It's not associated with the network ID. So I want to mask this number off in a way that makes it invisible. I'm going to do that by ANDing it with all 0s. And again, if we go over here to our little table, we see that anytime a 0 is present, I end up with a 0, because they have to be all 1s to get a 1. So no matter what number you have here, you're always going to get a 0. So if I apply this mask the way I've just described it, like this, to this IP address, the one that I described earlier, here's what I get. 131.161.0.0. And I can refer to this as the network ID. Every host in this network is going to have this network ID. It's going to start 131.161. It could be .10.20 or 20.10 or 100.200 or whatever it is, but it doesn't matter because since I'm masking it with zeros, I end up with zeros. And as I pass this packet around the internet to various routers, each one of them will look at it and they'll say, oh look, you're showing me this network ID, I'm going to ignore this part. So for each one of these classes of addresses, the default mask can be determined by this number here. I'm only going to reveal one octet for this one, so the default mask